Have you ever gotten a lab result back and just stared at it? Because you feel one way, but the numbers on the page are telling a totally different story. Well, today we're going to dive into one of the most confusing paradoxes in biochemistry, and it's something that affects way more people than you might think. Okay, so picture this. You're just not feeling right. You're tired, maybe dealing with some brain fog, the classic signs that make you think, maybe I'm low on a vitamin. So you do the right thing, you get your blood work done, and the results are just baffling. They show your folate levels are high. How in the world can that be? Well, let me tell you, this is not just a random fluke. It's a very real biochemical paradox, and we are about to unravel it together. So here's our roadmap for today. We'll start with the B12 folate puzzle itself. Then we'll uncover something called the methylfolate trap. From there, we'll get into why getting this wrong can be so dangerous, look at a few other culprits for confusing lab results, and finally, we'll talk about how to get the true picture of what's really happening in your body. All right, let's jump right in. The B12 folate puzzle. What most people assume about how these two work together is, well, it's actually completely backward. So let's flip that idea on its head and see what's really going on. Okay, this right here is the absolute key. The intuitive thought, right, is that a folate problem might mess with your B12 levels, but the biochemical reality is the complete opposite. It's a B12 deficiency that can make your folate levels look falsely high on a test. This one simple reversal is the key to understanding literally everything else we're about to talk about. So the big question is, how? How can a lack of B12 possibly lead to what looks like a surplus of folate in your blood? Well, it all comes down to this fascinating process known as the methylfolate trap. But before we get into the trap itself, we need to quickly define one term: coenzyme. Just think of it like this. If an enzyme is a car engine, the coenzyme is the key that starts it. Without the key, the engine is useless. It's not going anywhere. And in our story today, vitamin B12, it is the key. So here's exactly how the trap works. Imagine folate is a delivery truck, and it has a really important package to hand off. To make that delivery, it has to cross a bridge. And guess what? Vitamin B12 is that bridge. So if you're deficient in B12, the bridge is out. The whole process just stops cold. Folate can't make its delivery, so it gets trapped. It backs up, spills out of your cells, and starts accumulating in your blood. And that is why your lab test can show high folate, even when your cells are actually starving for it. Now, understanding this isn't just a cool piece of science trivia, misinterpreting these results can lead you to try a fix that actually creates a much, much more dangerous situation. And this is where things get really serious. Let's say you see that high folate on the lab, but you feel awful. That's a huge red flag for a hidden B12 deficiency. Now, what happens if someone just throws high-dose folic acid at the problem? Well, it can actually make the related anemia look better on paper. But, and this is a huge but, it does absolutely nothing to fix the underlying B12 deficiency. The real problem gets masked, allowing serious and sometimes irreversible neurological damage to just silently progress in the background. And this really gets to the heart of it. A corrected symptom is not a corrected cause. We can't ever confuse a better-looking lab report with actual, genuine healing. You've got to treat the person, not just the piece of paper. And it might even get worse than just masking. Some of the latest research suggests that flooding your system with folic acid when B12 is already low doesn't just hide the problem, it might actively use up the little bit of usable B12 you have left, potentially accelerating the very damage you're trying to prevent. Okay, so the folate trap is a huge piece of this puzzle. But what if that's not the whole story? It's really important to know there are other reasons a B12 test might come back high, even when you are genuinely deficient. Yeah, let's look at a few other culprits. For one, your standard lab test can get fooled. It might be counting both the good, active B12 your body needs and these unusable, inactive pseudo-B12s. Or, in certain autoimmune conditions, your own body's antibodies can actually interfere with the lab test itself. Even issues with your liver or kidneys can cause stored B12 to leak out, which skews the results. The big takeaway here is that a single B12 number isn't always the whole story. So, with all these potential pitfalls and red herrings, how do we actually get an accurate diagnosis? Well, fortunately, we can look past those simple serum levels and actually measure what's happening deep inside our cells. And this is how we get the true picture. Instead of just counting B12 floating in the blood, we look at what it's actually doing. We measure these things called secondary markers. Think of them like metabolic footprints. A substance called methylmalonic acid, or MMA, for example. It only goes up when there's a true B12 deficiency. It's an incredibly specific clue. Another one, homocysteine, can be high in either a B12 or a folate deficiency. So by looking at these markers together, we get a much clearer, more functional picture of what's really going on.
Okay, so let's just quickly recap the crucial points here. First, a B12 deficiency can cause that methylfolate trap, leading to falsely high folate levels. Second, trying to fix it with folic acid supplements is dangerous because it can mask the real problem. Third, that masking allows irreversible neurological damage to continue, even if the blood work starts to look better. And finally, to get the real story, you have to look beyond the standard tests to functional markers like MMA.
You know, this whole thing leaves us with a much bigger question. In this age where we have more data than ever at our fingertips, this paradox is a perfect reminder that a number on a page isn't the same thing as understanding. It really pushes us to ask, are we measuring what truly matters for our health? Hey, if this explainer helped you make sense of a really confusing topic, do us a favor and hit that like button. And make sure to subscribe for more deep dives that make the complex clear. Thanks for watching, and we'll see you in the next one.